Now, in the United States, it's very common that students will be very familiar with solving quadratic equations by factoring, but that they'll have a hard time solving them when there are imaginary numbers or rational numbers, fractions or decimals as the roots of the function. So when that happens, usually the most straightforward path is to use the quadratic formula. So you have to have that memorized for this type of situation. If you don't have it memorized, write it in a card, try and memorize it, hide the card, try and remember, look at it again, try and copy it down 100 times, 10 times, 20 times, whatever floats your boat, whatever method works for you, but memorize the quadratic function or the quadratic formula, to have it in your back pocket, something up your sleeve in case you need to use. So in this case, right, I'll write it down for you. Remember that the quadratic formula tells you that x equal to minus b plus or minus the square root of b squared minus 4ac over 2a. In some books you'll see this referred as delta. So sometimes you'll see minus b plus or minus the square root of delta over 2a, and delta being the discriminant, b squared minus 4ac. So it's the same process, whatever you want to do to memorize, whatever works best for you. The reason why people use delta here is that this is a good indicator, this is a good place to start. So I'll start by computing this guy. B, remember that b is minus 6, so maybe I'll indicate that. This is b right here. A is 1 right here in front of the x squared, and c is 10. So delta is minus 6 squared minus 4 times a times c. So that will be 36 minus 40, so negative 4. So the reason why people split the delta up and calculate it first is this. Whenever you see a delta negative, there's no real solution, but there are imaginary solutions, because you're going to have to take the square root of delta, right? And the square root of delta is going to be the square root of negative 4. So that's non-existent in the real numbers, but it is a complex imaginary number. So the way to figure it out is to plug this into the function. This is minus b. So remember, b is minus 6, so this is minus 6 plus or minus the square root of negative 4 over 2 times 1, so just 2. So 6 plus or minus, so what is the square root of negative 4, right? It does not exist in the real numbers, but how do I find it in the imaginary numbers? The square root of 4, I know, that is 2. So I'd wish it were 2, but it can't be, because 2 squared is positive, so I add an I here, right? And you can even check that doing 2i squared and noting that that equals 2 squared. I'll do that at the bottom there so you can see it better. 2 squared times I squared, and that's 2 times negative 1, because I is that imaginary number. That squared equals negative 1. So that is negative 4, right? I forgot a squared right here. So it's 2 squared and then I squared. That's what I have. 2 squared times I squared. That is 4 times negative 1. So negative 4, which is exactly what I wanted it to be equal to. So that's what I have, 2. And whenever I have addition here or subtraction, I can use distributive property of division as well. So I got to divide both the 6 and the 2i. So that is 3 plus or minus I. So these are the two solutions, and I can even write it formally to say that the solution is 3 plus I, comma, 3 minus I. I think that'd be the best way to indicate your answer in that case. Just a list of answers. The problem just asks for a second part, which would be just to check if you're okay manipulating complex numbers in general. I'm asking you to compute x1 divided by x2, where x2 is the 0 with positive imaginary part. So the bottom has positive imaginary part, so the bottom is 3 plus 1, or 3 plus I. That's the positive I part. And the top, just the only alternative for the top is the other thing, so just 3 minus I. So be careful with this part, because I could very easily change that and say x2 is the 0th negative imaginary part, or x1 is the 0th positive imaginary part. Or I can ask, instead of x1 divided by x2, I can ask x1 times x2, or x1 plus x2. Right, so just be careful. Make sure you understand how to perform operations in complex numbers, so you're not surprised by this question, or this type of question in general. So here, how do I perform this operation? Division of complex numbers usually requires you to use multiplication by the conjugate. So you take the bottom and you multiply by its conjugate. So this is the complex conjugate. You repeat the number, or the complex number, but switch the imaginary part, switch the sign of I, right? And then you just multiply by like normal. So you go 3 times 3, 9, minus 3i minus 3i minus I squared, or plus I squared, right? Because it's minus with minus, it's plus I squared. And then at the bottom, I have 3 with 3 with minus I, so 9 minus 3i plus 3i minus I squared. And that is exactly why we did this, so that the i's would cancel. You always want that no i's show up at the bottom of your fraction. So that will be continuing, right? A 9 minus 6i, and this is minus 1. And then at the bottom, a 9. This is minus 1, so plus 1, because I squared is minus 1. So finally, this is an 8 minus 6i over 10. So I can divide each separately. So 8 tenths minus 6 tenths I. Okay. I'm also told to simplify my answer, so I actually want to divide this. Maybe I could have used my space a little better. So let me make a small adjustment so you can see. I want to divide each fraction simplified by 2. So simplify this 8 tenths by 2. That's 4 fifths. And simplifying the 6 tenths by 2 is a 3 fifths I. And I box this because that's my final answer. I hope this was clear, but don't forget to think of different possibilities for each question you're solving, just so you're prepared in all cases.